Okay, it's 10 past 9 o'clock. Good morning and welcome back to Introduction to Scientific Computing with Python. Are there any questions from last lecture, last material? You went through the material, any questions? Did you find the material in Cyber University? Yes, no, maybe? Still too easy, right, to make a big deal about this. So what did we do last time? Last time we started looking into some basic elements of programming. We looked into Boolean values. We looked into simple function definitions. And what you should remember, right, is that when we define a function, wait a little bit. When we define a function, we have different parts to it. The first part is the def keyword, def. Let's see if I have a pointer here somewhere. Def. That is a function name where we apply the naming convention as we use also for variables and other objects. Followed by round, brackets, and a colon. And then there's an indentation, and then you have just any expression. Right. If possible, please use, now everybody pay attention, right? Use print, not that excessively. Use it only a little bit. Use it if you want to debug, if you want to follow the program flow interactively. It's not how you communicate information from function to function within the program. Right? So if you want to have a result of a function, right, of a logic block of code, return the result wherever you can. Because if you return the result, you can catch the result as a variable and then further use it. With print, you cannot. It's lost then, okay? So if you write print, at the moment you write print, ask yourself, hey, do I need the value later on? Then change your print to a return, okay? Good. So what else did we do? A few examples on print. How do we call a function? Here's the general syntax, right? We need to give it a function name followed by no one or several arguments. If we want to If the function has a return value, we want to make use of this return value later on. We can catch it, right? By a variable assignment. Here, the whatever function name is returning will be stored into value, right? Good. Next example, my square function. This is what we did together as well. That's a very simple function. It returns the square of a. We can click on it, right? Execute this piece of code to check if it really works. Execute again and get 4. Now, the funny thing with Python is, let's see if we return a square. What's that? A string square? No, it does not. Okay. So numbers work fine. Letters do not. Yeah? Well, that's also a letter here because it's a string. Okay, what else can we do? We can have another example. Just to recap a little bit. Now by addition. And not my ass. Good. We'll have this and we execute this function. My add 2. 2 plus 2 is 4. Very good. But now if we add a letter, a string, 2a is what? Now, a. Okay, a little different because the plus symbol for strings is defined as concatenation. Meaning we just put the strings together. But we have not defined what is the multiplication sign for string. That's why the my multiply function gives me the error, but my add works out just nice. Okay. So question, is it possible to get the result of my square without using the return command? So here, right, if you inspect closely the differences, instead of return, we have print. We execute, get result, but if we want to store the result of my square to a new variable, yeah, it doesn't work. Right, so this is again the difference between print and return. So whenever you think you use print, to think twice and make sure you do a decision. We can give more than one variable to the function. So we took pass 2 arguments in our function definition. We use 2 arguments. The example looks fine. So my sum here we have a and b. We pass a and b as a sum to c and return the c value. So when execute my sum with the arguments 2 and 3, it works fine. Now what happens if I put more arguments? 2, 3, 5. Then Python will tell you, hey, I expected 2 arguments, but got 3. So there's a way around in this in Python to give an arbitrary amount of arguments, but become data to this. And for now, stick to the plan, keep it simple, and later on we will do more complicated cases. Okay, but we can still make the function a little bit more compact. So my sum version 2. Previously I written c equals a plus b. That's a line I don't need. I can just write the sum of a and b directly into the return command with the return keyword. Also works fine. So I can save a line, make my code more compact. So making your code compact can add to well, keep your code readable, but if your code becomes too compact, you lose your readability of the code. Right? What you basically want is you write code once, and then you give it to your friend, and your friend knows exactly what's going on. So your friend can use your code. If in a few years you left university and the code is still circling around because it's the best code to analyze XRD spectra or whatever, right? But then some packages update and you need to fix your code because something is not compatible anymore. And your code is not readable. As we basically must throw the code away or write it from scratch again. So keep your code readable, right? So many people can use it and don't have to do the same thing over and over again. Also, right? Think about yourself. Suppose today you write a code and in 2 years you want to integrate it, right? So you take it out again and then use it again, but you forgot how it's working. And so you don't want to keep your code readable as much as possible. Okay, here, for example, my function, two arguments, it returns the negative of A, right? And it returns the negative of B multiplied by over 10. This is interesting because it allows us to return two values at the same time. We can even return more values than so if I return more values, I also must catch more values, right? So over here, I'm going to see. Okay, so I can give as argument to a function 0 arguments, 1 argument, 2, as many as I like. I can return as many arguments as I like. And you can assign them in one go. So that's good. So there's great flexibility in how Python handles receiving information in a function and returning information of a function. What you should not do in the returning function is to use print. Okay? Do not use print to return information. Use return. That's why it's called return. So I highlight this often because in the past years, right, I always have seen the mistake that students end a function with print. But then it becomes a useful function, right? You want to return the value. Okay, so if, for example, I don't need C and I still want to execute this line of code like this, right? So no equal and press equal, or there's arrow, you can skip this arrow just putting an underscore here, okay? Now C was defined already, but we don't have to write C, right? So the function returns many values, but you don't need all of them. You can make them basically pass a template of a name and an underscore. Let me see something. No, test of this actually. Underscore becomes a name. Interesting. Okay. Write a function. Oh, don't show you the solution. Write a function that subtract two numbers. Can you do this? Write a function that subtract two numbers. There's a task here. By the way, you have those slides inside the university, right? Yeah, it's all inside the university. But it's slides, not its notebook. So everything I show you in the mornings, right? It should have the name here. Here's the name in case you don't see. 1.2 function, program, flow, and data structures. That's inside the university. Should be. So nothing that you see here is like, I don't know, good. Okay, so task, I want you to try a little bit so I see how much of the information I try to convey to you, right? As an argument in our bucket, giving to you how much is received, right? And then you try to return your solution to me in one or the other way. So now, when you're supposed to write a function that subtracts two numbers, what do you do? Well, obviously we have the addition of two numbers here. So the simplest way would be you copy the example from above, right? Then you, oh, here this is the task, I can do this easily, huh? And I just put a minus here, right? But this is basically what my standard solution here looks like. So whatever we do here together is just a small modulation what I've tried to introduce. But the small modification, one is supposed to challenge you a little bit to see if you've understood the basic concepts. If you have not understood the basic concepts, raise your arm to ask the question. If you are too shy to raise your arm, push your friend where you are, then they scream, oh, I'm pain, then I also know that something is off, okay? If you don't want to help your friend, you can ask your friend to raise the arm for you. Nobody has a question? Everything too easy? The other secret I tell you, the more questions you give to me, the slower I become. That means, right, we spend more time on the easy things and don't rush too much into the complicated things. Still easy? Easy. Okay. Minus a function. Okay. Okay. So write a function that multiplies three numbers. So I can scroll a little bit further, but then you already see my solution. I go here and add some empty lines. No, no, don't see my solution. Here. Here. Next task. Exercise. Write a function that multiplies three numbers. So far, so good? Okay. A little bit more time. So how do you multiply three numbers? Adding, no problem. Very good. No problem. Very good. Very good. What? Oh, compare three numbers. Okay. Yeah. Yeah. Three numbers. Very good. How about we do something else? Something a little bit more offset. How about we want to compute A minus B times A plus B. Can you do that in a function? You do your solution, I do my solution, because that's like on the fly task here. Yes? So you have your solution, I have my solution. What do you think about my solution? Somebody has the same solution? No? So you probably have like A minus B times A plus B like this. Yes, no, maybe? You must have the brackets, right? Otherwise you get nonsense. Well, not nonsense, but not the thing I wanted to have. Okay, so what's the difference between view? So I try to now with lines here. Does it do something? What's the difference between my line 2 and line 3? So you know what's the difference, right? So what's the difference? Hmm? Yes. So we are using uh, basically not the direct expression here, but we use the function we have implemented above. So we make use of what we did before. So here my subtraction is A minus B, and it seems to work properly. And what else do we have? My add. Where's my add? How about we replace my add with my sum? Just couldn't find my add. So now the question is, what do I only want one return value, right? So I can put a hash in front to say, keep that line there for humans to read, but for the Python interpreter, skip the execution, right? There's nothing in the programming language here, just skip, right? So, okay, I push enter, and now isn't that a funny name here? What do you think about my function name? Is that a good function name? Who thinks it's a good function name? I think it's the best function name I ever made. Who thinks it's a bad function name? Who can read it? What is this? But, well, thank you for asking. It is add A minus B, A plus B. Obviously, everybody of you know that, right? Now you know. Will you remember this in 2 years? You will. Nobody will remember this. Keep your code readable. So what's a better functioning? What's a better functioning? How did you call that function? Any good functioning? The same. Oh, very good. Well, calcul, that's also not very good. How do you call a minus b, a plus b? What kind of formula is this? What kind of formula is this? You know this from high school, right? Yeah, yeah, but what's the name of the formula? A, by, okay, okay. A square minus b. But it's at least readable, right? I mean, you can make it a little bit better, like A square minus b. Okay, so then there's some things I expect you to know from high school, right? If you don't, repeat them. But there are some very, very fancy names like binomial, first, second, or third formula. Look it up, see what it is, and then at home fix that name. But for now, we keep a squared minus b squared. Very good. Because it's at least readable, right? Okay. So, other thing, right? It's a very, very long function name. So I just write the first two lines and I push the tab button, right? And Python completes for me. Let's see, what do we have? 2 and 2? No, because 2 and 2 is 0, right? So let's try 3 and maybe 5 and 2. 21, is that correct? 5 minus 2 is 3. 5 plus 2 is 7. 3 times 7 is 21. So that's a good, right? Okay, but in summary for this small size, keep your names readable and you can make use of the functions we have defined before in your function. Right? So whatever you have programmed before, you can and you should make use of. Try to minimize to write the same code as much as you can. Right? Because it saves you time, not only writing the code, but also debugging the code, right? Making sure that everything is correct. Okay, so my multiplication, 3 numbers, it's fine. I went around, I checked a few, and good. So you all got the note. You can 3 arguments to a function, you can multiply them, and you must put the multiplication sign between the symbols. If you right, simplify as we do on analytic maths on with pen and paper, skipping the dot of the multiplication, this will not work. Right? I will tell you invalid syntax because between variables we must put the arithmetic operation or the symbol of the arithmetic operation to be sure I know what's going. Good. Now fix my code. Function 1 is already fixed. Always. Oh, no, it's not fixed. There's the solution. So you check the notes, remember to put the code in here. That's a common mistake. The 2 dots at the end of the function definition, keep them. The symbol I mark here, right? This here, my point is empty. But there's 2 dots on top of each other. This is called colon in English. I think it's pronounced like this. Okay. Right. Another mistake is indentation. What else is wrong here? The Python tells you I expected this one. I can tell you what it is, but it's the rounded bracket. What do we have? Square brackets. We change this. Very good. It works. How about this one? We skip over it so quickly. What's the error message? It's the indentation error. What's an indentation? It's like we already like in this one here, right? I push it inwards. Indentation. Okay, it comes back first, but our code has our code has a lot of indentations, you see? Right? Last time the indentation was like this one here, right? But still indentation error. But the thing is, so the indentation, you can have 1, 2, 3, 4, 5. They will give you a different hierarchy, like a matroshka. You know what's a matroshka? This Russian nesting dolls. You put one inside the other, inside the others. They give you a different hierarchy. You must make sure that your code that lives on the same uh, uh, um, basically purpose, right? I said lives on the same purpose, meaning it tries to solve the same problem, uh, has the same indentation. There we go. If you have one code block inside the other, that can also be okay. But then this code block has a special meaning within this larger code block. Okay, we come to this. Let's see it. Oh, here, this nice. Mm-hmm. So let's study this code first. What's going on here? Can you read this code? What's function 4 do? So if I ask you to read code, it's going to line by line, right? Just say what it does basically first, right? So first line, we use the def keyword. When you say what the def keyword is doing, to define a function. The function name is fun4. It takes two arguments, a and b. In the next line, we take the sum of a and b and store the value in C. In line 3 of function 4, we use the def keyword, right, to define the function fun5. Also take two arguments and subtracting a from b, so b from a, store the value in C and return C. So now let's see what's happening. So we call function 4 and we two arguments, 2 and 3, and 5 is returned. So actually, when we execute this function, we enter the last command that is returned C, which is defined over here. But now I can do like a function call, have a function call with A and B. Execute this already. So what I want to see is that actually -1 is being returned. Okay, so the program doesn't behave as I wanted. So what do? I use the print command to check. So what's going on? So the function does call function 5, right? When it calls function 5, it jumps into the function call and prints over here. So I know that function 5 is returning the value 5. So a minus c. So we can have here a print c, sorry, and then print the value of c. Right, so c is -1. Very good. So don't need this print command anymore. Okay. So here, function 5 is returning c. But nobody captures the value from function 5. But I can say here, c equal, put the return value, and now, right? Function 4 is also returning -1. Good. So I don't need to print anymore to follow what the program is doing. Finally. Okay. So c is -1. So this was one part of this example was this how I use print in these simple setups to follow the program flow, see if everything is executed as I think, and find issues and fix them. The other part of this is, hey, I have defined function 5, right? I can just call function 5, much easier. Okay, let's just call function 5. What's this error? Can you see this? Name error. Function 5 is what? Not defined? This is impossible. It's defined over here. I use it over here. It worked just fine, right? Now this is so weird. So function 5, because it is defined within function 4, it can only be used within function 4. It's not known outside of function 4. So it's some kind of a locality of the function and actually variable definitions. How do we know it is defined within function 4? Where do you see this code indentation here? That defines one logical block. And function 5 follows this indentation. And then to define function 5, I use an extra indentation. Right? So this indentation now says, okay, whatever is here is the definition of function 5. When I leave this indentation after return, this part is still the definition of function 4. So I have two options. You also need to consider your options here. Either this locality of variable definition is wanted by me because I want to keep some things hidden, right? So nobody messes with them. Some very important functions, some functions that are maybe better defined by me, and so on. Or I say, well, actually, I do not care so much. I can give access to everything for function 5. So I just take this function definition, shift it to the same level as the definition of function 4, which should be here on my global level. I execute. It is still known to function 4 because everything outside is known as well, right? So I still can make use of function 5 within function 4. But I also can make use of function 5 explicitly. So far, so good. I see a few, at least, stunned faces. Like, oh my god, what's going on? Why does this matter so much? So is that about right? Do I read your faces correctly? Or is that like too easy? No, yes, maybe. For questions, we just continue, right? And then, well, you always have slides as information. You can ask the TAs, ask me. Okay. So notation gives hierarchy of expressions and functions, right? Hierarchy, what is that? Hierarchy is, well, parts of a system that are basically nested into each other. For instance, a system into different levels of importance from highest to lowest. It's a little bit like Taiwan's political system, right? You have a president, then you have country governments, then you have city governments, and you have local governments. They're all one big organization on different levels. So code indentations are important, or code blocks are intended once a header line with a colon appears. And so the colon is the key part here. As soon as we have this, we have an indentation. All statements at the block must have the same indentation. That's how we basically structure code blocks. Code blocks can be nested within each other. We have seen this just with the function definitions. All code in a block has the same indentation. So this has the same indentation appeared twice. So it must be really, really important. Okay? So whenever I repeat something, it's really important to me. Because I really don't like repeating myself. So not using the print function to return values in a function is really important. Okay, okay, you got that right. Good. Indentation most often achieved using 4-space increments. Last lecture I showed you we don't need to use the tab or the 4-space indentation. A single indentation could be okay. 10 indentations could be okay. The same indentation is the thing that counts. You're not something. It's okay, don't worry. It's switch this off. Normally I just switch it off and on again. Yeah. Okay. Comments, questions so far? Everything like easy, a little bit easy, a little bit difficult, a little bit abstract, right? You need more time to code yourself. Okay. Oh, I have to switch on here as well. Yeah. A bit stupid. Okay, and we continue like this. Thanks. So here are examples, right? Same indentation within one code block, right? But different code blocks could have a different indentation, right? Okay. Some special functions. Type conversion. Already showed you how we convert an integer to a float, right? We use the int function int. Here again, we have an integer, a float, and another float. We execute that piece of code, and we see I2 is an integer. We can even confirm the time. And then we can check if this type is equal to the type the in function is returning. Hey, and this is true. Okay. We have a float maker, right? A float conversion function. So any value passed here to float will return a float number. No value passed to this function. You see, this is a function with no argument given. It still returns a value here, 0, 0 as a float. We can put in -1. Okay. How about we put a number, a string into this, a? Nope, that doesn't work. Right, so we must give a number. So far, so good. Let's see how many digits we can give. Sorry. A lot of digits, right? Pass an argument. Does Python do something? No, it will account. So there's something called machine accuracy. It ends usually at 16 digits. Usually, right? There are exceptions to this. Some even only 8 digits, depending on the language what you use. Right. So if you want to have the 1 at the end, we need to make sure we have not too many digits. Ta-da! Very good, it works. Remember, this links to the example with the rounding errors of the Boolean comparison between some number divided by 3 plus 1 times 3 is different than, like what you said, the number plus 3. We did this last time. There was a rounding error. Be careful with your rounding errors because they happen, and you must be aware of it. Right. Convert a string or number to a float point number, if possible. Right. But we saw A is not possible. There's one way of converting a character to a number following the Unicode. Maybe we do this after the break. Let's see what else do we have. We have the type function to see what type we have. We have the Boolean function to check how the Boolean is working. So bool, just empty, returns what? False. 0 returns false. Anything other than 0 returns what? True. 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 So only 0 returns false. Everything else is true. It's like having no value and a value. Do you have money in your wallet? Yes. Do we care how much? No. Okay. Check. Sensitive to invalid syntax. Not true is false. Makes sense. False is false. False is Boolean. Nothing to convert here. Else can be a float number. That is false. How about rounding errors? What do you think will this give? True or false? Are you sure? Are you sure Python will do a rounding error here? So this is true because this number, if we put this into a float, will be 1e minus something, right? Which is pretty, let's say, above float. 1e minus 33. How many digits has this number? So this is not what meant by my machine accuracy, right? Because in principle, this is 1 digit, right? And that just tells you how far this digit is away from 0, right? In decimal positions. But if we would put the 1 here, let's start 1 here first, then we lose this because the distance between e to the power of 0, which is 1, and 1 e minus 33, that is too much for the machine accuracy. So we just round it, right? But at that moment, the value will be 1 and therefore 2. Again, be mindful of your digits and how they relate to the leading number and your decimal place. Okay. What else? Now it's 10 o'clock. Do you want a break or do you want to continue? Who wants a break? Hands up. Very good. Okay, then we have a break.